Hello, I'm Mike McCulloch. Today I'd like to talk to you about Maxwell's demon and the consequences of that for quantized inertia, where it comes in. So Maxwell had a very long, well, not so long, but a very prolific life, and he did a lot of useful things. One of the latter thoughts he had was his demon, and which really upset thermodynamics at the time. So what he imagined was that there was a box. So that's shown here, somewhere around here. And you can see that there are molecules in this box, shown by the red arrows, which are moving around at random. Some with small speeds, small energy, and some with large speeds, large kinetic energy. And then you can see in the center, there's a partition, and the demon is above the box, and he's able to move the partition. Now it turns out that if he has information about the motion of the molecules, if he has information, which is a crucial factor here, then every time he sees a high kinetic energy molecule moving from the left to the right, he can raise his partition and let it through, so that over time you will have in the box a lot of high energy particles on the right hand side and all the low energy particles on the other side. And Maxwell pointed out that this represents a transition from a high entropy system, so a very random distribution, to a very low entropy system, a distribution which is quite unlikely, all the fast molecules being on the right and all the slow ones on the left. That's low entropy. And according to the laws of thermodynamics, entropy is supposed to go up. But here it wasn't. So what was going on? Well, Szilard came along a few decades later and talked about Szilard's, what's now called Szilard's engine. So he pointed out that yes, this is true. Maxwell's demon can put all the high energy molecules onto the right hand side. And then what you can do is you can put in a turbine and use them to generate electricity. So in this diagram I've shown this. You can see the turbine there in the center, upper center, and the demon is now an electrician because he's generating power. But Szilard also pointed out that what could be happening is that in the engineer's mind, in order to decide whether to raise the partition or not, depending on his information, he has to process data, and it could be this that's releasing heat energy, and this is going out into the universe, and it's increasing the entropy of the universe more than it's decreasing the entropy of the box, and so thermodynamics would be happy. And then 1961, Rolf Landauer came along. He worked for IBM, worked with computers, and he wondered exactly which part of the process in the engineer's brain would produce the heat that would satisfy the second law of thermodynamics. And he reckoned it was erasure of information, because he was working with computers and he knew that if you have a computer which has a series of ones and zeros as shown here, so 1101, and then suddenly wiped it so it was all zeros, that represents a reduction of entropy because you have a complex system being reduced to a simple one. And so that would mean that heat would have to be released, and so in a computer the erasure of data generates heat, and this is now well observed as well. This has been observed, and so presumably also in the demon or engineer's brain, the erasure of information would also release heat. So every time he decides whether to raise his partition based on the motion of a molecule he sees, when he goes on to the next molecule he has to erase the previous information he had, so this would allow a release of heat. So this would mean that we now know that entropy is still going up, so the second law of thermodynamics is still okay, but more importantly, it means that you can get energy from information. And I use this in quantized inertia quite a lot, because whenever you set up a horizon in the cosmos, whether it's a cosmic horizon or a Rindler horizon behind an object, it represents a reduction of the information the accelerating object can know about the universe. And so that would release heat, and it turns out that that heat is exactly what you need to predict the inertial mass in quantized inertia. It comes out very simply, and I've discussed that in a previous video. So I think this is significant because it gives us a new potential source of energy, which is information, which would be very useful. Okay, so I hope you've enjoyed this short. Please do subscribe on Patreon, and I look forward to making another one of these for you next time. Goodbye.